Hello everybody, so in this video we will be looking at the lead code problem 74, that is search a 2D matrix. So the problem statement states that we are given right, we have to write an efficient algorithm that searches in a m cross n matrix and it searches for a value target, and the matrix has the following property. So the properties of the matrix are integer in each row are sorted from left to right. Okay, so that means each row is sorted and the first integer of each row is greater than the last integer of previous row. So the first integer of each row, that is this one, will be greater than 7. Here 23 will always be greater than 20. These are the two properties of the array. So how can we do that? And here our target is 3. So if I see this test case, so we see our target is 3 and we need to search it. So what we can do as a brute force, what we can do, we can just traverse our matrix. We can traverse our matrix 0 1 2 3. We can keep I here, j here, and we can just generally traverse our matrix and search if my matrix of I j equals to target. If yes, then I'll just return true, that the value is in my matrix. Yes, I have to return true or false. So the time complexity for this approach will be O of n cross m, and the space complexity will be O of 1. But we can optimize this approach. This is a brute force, so we can optimize this. So for the optimization, what we can do, let us take my matrix again. So what I can do, as I know each of the rows are sorted, so first point is this optimization technique works because each of the row is sorted, and as I can apply binary search as rows are sorted. So for each row, for each matrix of I, where I is from 0 till n, from 0 to less than n or n minus 1, I can apply binary search on each of these, and this approach will take a time complexity of O of n log n, where n is for traversing each row and log n is the time taken by the binary search, and the space complexity will be rough 1. Now we can further optimize this approach. What we will do, as we know that this value, will always be greater than this value will always be greater than this value, and each row is sorted. So if I write my matrix in the form of an array, what I'll get is this. So that means my complete array with the array I'll get is sorted. So if I go from here, then here, and then here, I'll get a sorted array. So, and then if I traverse my this array, so what I will get a sorted array, and if I apply a binary search on this array and search for the target, I'll get my value, and this one will take O of log n plus log n plus, to put these values in this array, I have to traverse my matrix and a space complexity of O of n. So I won't suggest this approach. So the last and the most optimized one is, what we will do, something like this. So if I imaginary give index to this is 0 1 2 3 4 5 6 7 8 9 10 11, the last index will always be n into m minus 1. So it will be from 0 to n into m minus 1, and now I will apply my binary search on this. So that is, if I write it 0 1 2 3 4 5 6 7 8 9 10 11. So now for the binary search, this is my low, this is my high, right? this is my high. Now what we will do, we will find the mid. So mid is low plus high, that is 11 plus 0 by 2, which will give me 5. So this is my mid. Now here my mid is 5 is this. So now what we have to do is, we know that this is 5 but we haven't stored it anywhere. So to get these indexes, row value and the column index, what we will do, we will do mid divided by the column size, that is m. It will give me I, that is row, and mid mod m will give me j. If we do this, if I do this, so it is 5, right? 5 divided by m is 4, so it will give me 1, and 5 mod by 4 will also give me 1. So I have to look at mat of 1 1. Mat of 1 1 is 11. So if it is 11, it is not equal to my target, which is 3. Then I'll see, okay, my target is less, so then I'll apply my binary search on this portion. I'll apply my binary search on this portion. My high comes here, my high goes mid minus 1, and then I'll again apply, and this time it will be 0 plus 4 by 2, which is equal to 2, and this is my mid this time. Now again I'll do the same thing, mid divided by m and mid mod m. This one will give me 2 divided by 4, will give me 0, and 2 mod 4 will give me 2. I have to look at matrix of 0 2. So in matrix of 0 2 I have 5, and my target is still low. So where was I was here. So this time I'll search in this portion. So my high is here, so my high is here. So now what I'll do, I'll again calculate the mid. So mid is 0 plus 1 by 2, right, which will give me again 0, and now I have to look for the 0, and will be 0 by 4 and mod 0 mod 4, which will be 0 0. Now I'll look at matrix of 0 0, which is 1. So now my low will be here. Now it will be 1 plus 1 by 2, which will give me 1, and I'll now look at this index. So let me just clear it. So I will this time I will look at 1 by 4 and 1 mod 4, which will give me 0 1. So matrix of 0 1 is this number, it is 3. Now I'll compare it to my target, so we get my value and I'll return a true. So this is the algorithm. Now if I will just write a pseudo code for this. What it will be, I'll have a value last, like I will apply this from 0 to n into m minus 1. So let me store this in a value, like let me take high is equal to n into m minus 1, and my low is 0, and I'll apply it till while my low is less than equal to high. I will do this. Now I'll need to calculate the mid. So int mid will be low plus high divided by 2, that is my mid. Now I know I can find my I is by mid divided by m, and my j as mid mod m. Now I check if my mat of ij equals to target, I'll return a return true, and if it's not, then I'll check else if my mat of ij is greater than target. If it is greater than target, then it means if this is my mat of ij, suppose, and this is my 0, this is my n into m minus 1. If mat of ij is here and my target is somewhere here, I'll change my high to mid minus 1. So my high goes mid minus 1, else my low goes mid plus 1, or in the end I'll return a false. So now if I code this, first of all I need the size. So int n is equal to matrix dot size, and int m is equal to matrix of 0 dot size. Matrix of 0 dot size will give me the column size, and my high is equal to n into m minus 1, and my low will be equal to 0. My loop will continue till low less than equal to high, and I'll find the mid, which will be equal to high plus low divided by 2, and my int I will be mid divided by m, and int j will be mid mod m. Now I'll check if my matrix of ij equals to target. If yes, I'll return a true, else if my matrix of ij is greater than target, I'll do high equals to mid minus 1, else low equals to mid plus 1. In the end I'll return a false. Now if I run the code, it should work fine. It is working fine if I submit it. So as you can see, it is accepted. So thank you for watching the video, and make sure to hit that subscribe button.